Every single day, America swallows more than 380 million gallons of gasoline. That is enough to fill nearly 3,000 Olympic pools every 24 hours. You pull into a gas station, squeeze the nozzle, and 2 minutes later, you are back on the highway. Simple, right? Wrong. That amber liquid in your tank just survived pressures that could shatter human bone and heat hot enough to melt lead. But here is the terrifying part. One tiny spark of static electricity during its transport turns that whole payload into a city-level bomb. We will unpack that bomb later. First, let us look under the hood. To understand how we got here, we have to rewind about 150 years. Back then, crude oil was barely a blip on anyone's radar. People mostly used it to refine kerosene for oil lamps, just trying to keep the lights on after dark. But in 1908, Henry Ford rolled the Model T off the assembly line, putting everyday Americans behind the wheel for the very first time. Almost overnight, the world developed an insatiable wild thirst for fuel. Gasoline went from being a useless byproduct thrown into rivers to the absolute lifeblood of the modern world. Now, if you ask most people where oil comes from, they picture massive underground lakes, just waiting for someone to poke a straw down there. But that is a total myth. Oil does not sit in giant open caverns. It is trapped miles beneath your feet, locked inside the microscopic pores of solid rock, like water squeezed inside a tight stone sponge. It is completely invisible, buried under millions of tons of earth. So how on earth do engineers find something they cannot see? They give the planet an MRI. Companies roll out massive seismic trucks that blast high-energy sound waves deep into the earth. These acoustic shocks travel miles down, bouncing off different rock layers and echoing back to sensors on the surface. Computers take those returning sound waves and translate them into crystal-clear 3D maps of the underground terrain. It is a brilliant piece of science, but getting a map of the treasure is the easy part. Actually punching through thousands of feet of solid ancient rock to grab it? That is where this story turns into a pure engineering horror show. Imagine trying to push a paper straw straight through a 10-story block of solid concrete. That gives you an idea of what deep drilling actually feels like. Engineers attach a heavy drill bit tipped with synthetic diamonds or tungsten carbide to thousands of feet of hollow steel pipe, spinning it at high speeds to grind through granite and shale compressed over hundreds of millions of years. Every 10 meters, they screw on another section of heavy pipe, repeating this relentless process deep into the dark depths of the crust. Down at those extreme depths, pressure becomes your absolute worst nightmare. You are tapping into pressurized pockets of gas and oil, trapped under thousands of pounds per square inch. If that pressure breaks free uncontrolled, the trapped oil and gas blast straight up the shaft like a violent volcano. In the oil industry, this catastrophe is known as a blowout. A single spark can transform a multi-million-dollar rig into a towering inferno of flame and destruction within seconds. So how do crews keep a deadly volcanic blowout from wiping them off the map? They rely on a heavy chemical concoction called drilling mud. Despite its simple name, drilling mud is an incredible engineering marvel. Drillers force this dense high-tech slurry down the inside of the spinning pipe. It shoots out through the drill bit, cooling the red-hot diamond teeth, while floating crushed rock fragments back up to the surface. Most importantly, its heavy weight creates immense downward force. This hydrostatic counterweight seals off the intense underground pressure, pinning the volatile oil safely inside the earth. Once the well stabilizes, iconic nodding pump jacks start rhythmically pulling that dark raw fluid up to the surface. But pulling crude out of the ground is only half the battle. Right now, that thick black sludge is practically useless for your car. To transform it into high-octane fuel, it must endure a brutal trial by fire. Welcome to the belly of the beast, the distillation tower, the beating heart of every modern refinery. This massive steel structure is where raw crude gets subjected to extreme thermal torture. Giant furnaces blast the raw sludge with scorching heat, pushing temperatures past 700 degrees Fahrenheit. Inside that inferno, the thick liquid boils violently, vaporizing into a dense cloud of mixed hydrocarbon gas that surges straight up the tower. Inside the tower, physics takes over through a process called fractional distillation. As the vapor rises, the temperature drops, and different chemical compounds cool down and condense at different heights along special tray levels. Think of it like a giant multi-layered cake sorting itself out by weight. The heaviest, thickest molecules cannot rise very high before turning back into liquid. They sink right down to the scorching bottom, becoming asphalt for our roads and heavy residual fuel for cargo ships. Move up to the warm middle trays, and you catch medium-weight compounds condensing into diesel fuel and jet fuel. Finally, right near the very top where the temperature is coolest, the lightest molecules rise and condense. That is where we trap light naphtha, the raw foundation for gasoline. When you break down the math, it shows just how precious every drop really is. From a standard 42-gallon barrel of crude oil, refiners manage to squeeze out only about 19 gallons of usable gasoline base stock. Now, you might think we are ready to haul this freshly refined fuel straight to your neighborhood gas station, but pump the brakes. If you poured this raw, unrefined gas straight into your car engine today, it would ruin your vehicle within minutes, potentially causing catastrophic internal damage. Why is raw gasoline so dangerous for a modern car? The answer comes down to a mysterious number you see printed on every gas pump in America, a number most drivers look at every single week without ever understanding what it actually means. That number is the octane rating, usually 87, 89, or 93 at your local gas pump. Most people think a higher octane number means extra power or premium speed, but that is actually completely wrong. Octane measures a fuel's ability to resist exploding under intense compression inside your engine cylinders. In a properly running car engine, the piston compresses the air-fuel mixture, and the spark plug ignites it at the exact right millisecond. But if you put raw, low-octane fuel into a modern engine, the heat and pressure inside the cylinder will cause the fuel to spontaneously explode prematurely, way before the spark plug even fires. This uncontrolled pre-ignition sends shockwaves ripping through the engine block, creating a destructive rattling sound known as engine knocking. Left unchecked, knocking will literally punch holes in pistons and shatter internal machinery. Refiners must blend precision chemical additives to boost that octane rating, turning unstable raw gas into reliable engine-safe fuel. Once the fuel meets those strict lab standards, it gets loaded into massive tanker trucks for transport. And this brings us right back to that terrifying city-level bomb I warned you about at the beginning. When thousands of gallons of liquid gasoline rush through rubber hoses and steel pipes at high speed, friction creates a massive buildup of static electricity. Negative and positive charges separate, turning the entire fuel tanker into a massive rolling capacitor. Down inside that dark tank, flammable gasoline vapors mix with oxygen. Under those conditions, a static discharge smaller than a grain of sand can ignite the vapors instantly, setting off a horrific chain explosion that will vaporize the truck, the driver, and anything nearby within a city block. To survive this deadly threat, tanker drivers follow a zero-tolerance safety ritual. Before a single drop of fuel moves, the driver attaches a heavy metal grounding cable directly to the truck chassis, bleeding off static charges safely into the earth. Advanced automatic shutoff sensors monitor fluid levels constantly to prevent overfills. It is a razor-thin line between a routine fuel delivery and total disaster. After surviving miles of crushing underground rock, 700-degree fires, and lethal static electricity, the tanker finally reaches your local station. Here, gasoline is unloaded into underground tanks using pure gravity, avoiding powered pumps to eliminate any risk of sparks. Next time you stand at the pump for those brief 2 minutes, remember that quiet liquid represents centuries of human ingenuity and absolute precision. It reminds us that extraordinary power often hides behind the most ordinary routines. Which part of this journey surprised you the most? Drop your thoughts in the comments below and hit subscribe to unlock the hidden wonders behind our everyday world.